Let us study magnetic field at a point on the axis of a circular current carrying coil. Let's consider a circular coil of radius A and center at O. Current I is flowing through the coil in anticlockwise direction. And Phi is a point situated on the axis of the conductor at a distance x from the center O. Consider a small section dl there on the conductor at M, whose direction will be in this direction. We have to find magnetic field due to this section at Phi. So we have to draw a line from point M to from point Phi, and let's take the distance R. Magnetic field due to this section dl at point Phi be equal to dv, then dv equal to mu 0 by 4 pi idl sin theta by a square. Here is the question. What is the theta? Theta is the angle between dl and it's a square, not it's r square, and the angle between dl and r square is theta. This angle becomes theta. This theta. As it is a 3D structure, so the angle between dl and r is theta, which is 90. So sin 90 becomes 1. We have to remember here we use the Weierstrass. The law was beta b is equal to mu 0 by 4 pi ideal sin theta by r square, where I is the current carrying in the coil, L is the small section, theta is, and R is the distance between I and the distance between the point from the section, and theta is the angle between dl and r. So dv is mu 0 4 by 4 pi into idl by r square. We know that the direction of magnetic field or dv is perpendicular to both dl vector and r vector. So, and using the right hand thumb rule we can determine its direction. Here the direction will be in vq. Let's consider the r vector makes angle alpha between with x. This angle is alpha. Sometimes some questions arise why we could not take it as theta, because we take dl vector and r vector and angle between them is theta. So how can we take the angle between r and x theta? Let's take it as alpha. If you resolve dv vector into its cos and sine component, then we get, as here angle is alpha, this angle must be equal to alpha because it is 90 degree, and the angle between this and this is, and that becomes 90 minus alpha, and this also 90 degree, so the angle becomes alpha because it's 90 minus alpha, so it's also become alpha. We get dv cos alpha and dv sin alpha. Similarly, consider another diametrically opposite section dl dash at m dash, and also we get db dash in the direction pq dash, and also dissolving it we get db dash sin alpha and db dash cos alpha, and db cos alpha and db dash cos alpha is opposite and equal to each other, so they cancel out, and we get db sin theta and db dash sin db sin alpha and db dash sin alpha, and that with the from that we can find out the magnetic field intensity at phi due to the circular conductor. We have the magnetic field intensity for the small section dl. For the net magnetic field intensity at phi due to the circular conductor, that's the net magnetic field intensity at phi due to the circular conductor is b equal to dv sin alpha integration from 0 to 2 pi v curve, 0 to 2 pi a curve, it is the circumference of the circular conductor. Putting the value of dv and sin alpha, we get mu 0 by 4 pi idl by r square into r by a. From the figure we get sin alpha. If VMO is the triangle and alpha is and MOV is 90, then from the figure we get sin alpha equal to R by A by R. Then here mu 0 by 4 pi I R square R A by R whole are constant, and dl, that's the we have to integrate that part. We get mu 0 by 4 pi IA by AQ, RQ into 2 pi A. Figure R equal to A square plus X square whole root. This value in equation we get V equal to mu 0 I square whole divided by 2 into A square plus X square power 3 by 2. Is the net magnetic field intensity at phi due to the circular conductor. If we find out at the center of the circular coil, that means if we find out the magnetic field intensity at the center of the circular coil, then the x becomes 0. Putting this in the equation v equal to mu 0 I square whole divided by 2 into a square plus x square power 3 by 2. And we get V equal to mu 0 I by 2a. The direction of magnetic field at a point on its axis is directed along the axis of the coil and is determined by right hand thumb rule. Thank you for watching.